Hey folks, good morning. Here's another frictional torque problem for us. Should only take about 5 minutes or so, maybe less. We have this rotating spherical shell with 4 equally spaced masses attached to it. 2 of the masses lie along the rotational axis, and the other 2 are located along the side. We need to determine the frictional torque required to change this rotational speed of 75 revolutions per minute down to 50 in a period of 30 seconds. Let's start with the sum of torques equation. On the left-hand side, there's only a single torque that's involved here, and that's the frictional torque, which acts relative to the rotational axis running through the center. Because of the configuration of this compound object, the trickiest part of the problem is figuring out the total moment of inertia. Here's a reminder of some helpful values for that. Since 2 of those masses lie directly along the rotational axis, they won't contribute anything to the total moment of inertia. Their distance from that axis, represented by lowercase d, is equal to 0. The other 2, however, live at a distance equal to the radius of the shell, capital R. So those ones will contribute to the total. This means the capital I in our sum of torques equation is the moment of inertia sum of the spherical shell and the 2 small masses along the side. Next, let's work on an expression for the angular acceleration variable. Since we have the rate of rotation at the beginning and end of that 30-second period, we can grab this rotational kinematic equation to help us out. Just subtract omega initial from both sides and then divide by time. That's pretty easy. Let's go back to our previous expression and plug in what we just obtained for alpha. From here, I'm going to factor out 2r squared from the first set of parentheses and the t from the second set, like this. Before we plug in our numbers and finish this up, we need to remember to convert the difference of our omegas from revolutions per minute to radians per second. And we can tack on some conversion factors at the end to handle that for us. Now it's ready. Here's that expression with all of the values inserted. Now for the important part, the answer. My calculator says that we get a frictional torque value of approximately negative 0.0524 Newton meters. And that's it for today. Thanks for watching, everybody. Have a great weekend.